Saxon Algebra 2 students, it's one of my favorite days. We're going to start talking about what John calls uniform motion problems, what I call dirt problems. Distance equals rate times time. We have 3 different kinds of these dirt problems. This is type 1. We learned them all last year. They make most students crazy, but here's what's fun. This information has been lurking around in the back alleys of your brain for the past few months, and it's made itself quite at home there. So when I call that information to the front again, when you call it with me, right, we're going to call it forward in your brain right now, it's going to be familiar. It's going to be kind of an old friend, or at least an old person that you recognize. And it's not, hopefully it's going to flow a little bit more smoothly this time than it did last year. Remember that this is the Lord of the Rings style. And that's important to remember when we're telling ourselves our stories. Frodo goes to the mountain of Mordor, and Sam goes with him every inch of the way. They go together. This is the distance of Frodo, and this is the distance of Sam, right? It's the same. Another way to look at this, still in Lord of the Rings style, is that they travel together to Mordor, right? This is the Shire, this is Mordor. They travel together, and then they turn around and they go all the way back home, don't they? There's the Eagles that give them a lift. They have the layover in Rivendell. It's different. It's a different journey, but we're pretending that it's exactly the same. So we might call this the distance to Mordor and the distance from Mordor. All right? In both of these examples, the first distance is equal to the second distance, right? I didn't call them 1 and 2 because I put little letters in there to help us remember what was happening. But you can see that in both of these, the distances are the same. And so we can use this relationship. The distance is always equal to rate times time. And we can expand this equation to say the rate of the first thing times the time of the first thing equals the rate of the second thing times the time of the second thing. This is our base equation for our type 1 dirt problems, the Lord of the Rings style. Okay, and that is what we're going to use to do these problems. The first distance problem is usually the easiest because we don't have the other types cluttering up our minds. So just rest and refresh yourself, and let's take a look at how these flow. Let me read you a story. It's about Roger and Judy. Roger, a second, I have to get my book closer to the light. Roger made the trip on Sunday, and Judy made the same trip on Monday. Roger traveled at 12 miles per hour. Judy traveled at 20 miles per hour. Blah, 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 blah. So, and then there's got information about times. I don't like to get bogged down in those details when I'm reading it the first time. I'm just trying to understand the story. So Roger and Judy are making the same trip on different days, and we're supposed to figure out how far they traveled. All right, so what I do first is I draw myself a picture. Please do that first. Here's Roger going on, I think, Sunday, and here's Judy going on Monday. I forgot what they said, but I'm pretty sure that's how it went. So I can see, oh, this is a type 1. This is just like Frodo and Sam going to the mountain. Roger and Judy are making the same trip. They're not doing it. They're doing it on different days, though. So that's fine. Okay, so this is the distance of Roger. This is the distance of Judy. I use little subscripts to help the words flow. Now, these problems give me information about rate and time. So even though I know that the distance of Roger equals the distance of Judy, that's not helpful to me. I want to blow it out using my basic relationship, and I want to say the rate of Roger times the time of Roger equals the rate of Judy times the time of Judy. This is my base equation because this is the information I've been given. I have not been given this. I've been given pieces of this. And you know John, he's usually going to give us 3 out of the 4. All right, so as soon as I identify my base equation, I make a list over here of all the stuff I'm looking for. Then I will go back into the problem and pull out what I can. That's why I don't even bother reading all those details the first time, because I'm not going to remember. I don't want to know yet. I want to get organized before I start worrying about all those details. So now I'm prepared. I figured out what the story is. I've got the right base equation. I've made my list. Now I'm ready to go back in and see what the heck is going on. All right. Roger traveled at 12 miles per hour. Roger, you're fast. All right? I don't know what he's traveling on. Pogo stick, razor scooter, roller skates. I don't know. He's cruising along. A bike, maybe. We don't have to worry about units in these. In a more advanced class, you might have to make adjustments if people were giving like their rates in different units. Or one person, they said, traveled this many days and this many hours. We don't do that. Our units just work out fine. Judy traveled at 20 miles per hour. Oh, she's even faster. So the rate of Judy is 20. And her time was 2 hours less than Roger's. Okay, so the time of Judy is less than the time of Roger. See how I changed that into an inequality? Because that's the way it's written. Her time was a number I'm ignoring. Her time was less than Roger's time. So first I write that. That helps me know how to adjust. Roger's time is bigger, so when I look at the balancing number, I'm going to want to subtract. I could add to her side. I'll subtract from Roger's side. The number is 2. We've run into this weird balancy thing before. Remember, always write an inequality first. Okay, so what we'll do is we'll substitute this in for the time of Judy. Time of Roger we'll just leave plain, and that way we'll be able to solve it and eventually figure out time of Judy, because we're supposed to figure out what? Oh, well, never mind. I'll talk about the question that John's actually asking in a minute. Okay, so here we go. Let's plug in. Buckets are essential. We're multiplying, so I'm using those buckets to imply multiplication. 12 times time of Roger, we'll just leave it like that, equals 20 times time of Roger minus 2. That got a little crowded, didn't it? All right, we'll rewrite 12TR, 12 times the time of Roger equals, now we're distributing, 20 times the time of Roger minus 40. All right. I feel good about it so far. Let's venture into negative land. Let's subtract the 20 from both sides. That cancels, and we'll get minus 8 times the time of Roger equals minus 40. Scooch up a little so you can see. Let's divide it by minus 8. And we get, I'll go up here to write it, time of Roger equals positive 5. Right? The two minuses cancel to make a positive, and 40 divided by 8 is 5. All right. And then we can figure out using this, the time of Roger minus 2 equals the time of Judy. So the time of Judy must have been equal to 3, right? So we think, okay, well, we've got it. That's the answer. We look back at the book, because you should always look back at the book and check to see that you've answered the question. And John asks, how far did they travel? All right, let me just flip to another page for a second so I can write that out. This is not the question we would expect. Because usually John asks us to be specific about the rate that they traveled or the time that they traveled, but how far? That's an unusual question. That is a question that implies distance. How far? That's a question that's asking about distance. And we know that distance equals rate times time. So what we have to do is for either Roger or Judy, and we'll do it for both of them just to make sure, we're going to multiply Roger's rate times his time. I have to do some flipping. I'm sorry. Roger's rate is 12. Can you see it? Roger's rate is 12. And Roger's time is 5. So 12 times 5. That suggests that he traveled 60 miles. That's his rate. That's his time. Let's try it for Judy. Judy's rate, she was going 20, right? She was cruising. Yeah, she was going 20, and her time is 3. Look, it turns out exactly the same, which makes sense because this is a Lord of the Rings style. So their distance is exactly the same. They took the same trip. So John is asking us not for their rate, not for their time, but their distance. How far did they travel? And for both of them, it's 60 miles. We proved it. We didn't necessarily have to do it twice. That was just me being extra. But we use this basic formula to answer the question, and we can do it for Roger or Judy. Make sense? That's kind of tricky, sneaky business. All right, there's one more of these problems, and then we have a short geometry burst. All right, example 22.2. Ready? This one's about Brer Rabbit. I don't know if you ever... It was a Disney thing called Song of the South, and it's been deemed to be fairly racist. The idea is that a Southern gentleman used to tell these stories to his kids and the people who used to sit on his porch with him. So it was meant to be this kindly old grandfather guy sitting out on his porch telling these stories about Brer Rabbit, this tricky little... Brer stands for, like, briar, like he ran in the briar bushes. But in Southern drawl, it kind of came out as Brer. That kind of... Right? Briar. A briar's like a patch of prickly vines. So the idea was intended to be that this old Southern gentleman was sitting out on his shady porch and telling stories about this clever rabbit and how he outsmarts all the other animals. The problem was that he was characteristically portrayed as black and in ways that now seem at best insensitive and at worst racist. So most people have backed away from these whole Brer Rabbit stories and considered them somehow racist. But I know that there's another frame of reference for these that isn't racist at all. That it's just, they're just funny old yarns told by a kindly gentleman. I know that, like, Splash Mountain is the ride at Disneyland that is based on Song of the South, which is based on Brer Rabbit, and I'm pretty sure it's gone by now. Disney announced they were just going to get rid of it because it was too controversial. Okay, so we're doing Brer Rabbit, but in no way do I intend this to be racist. It's just stories from a kindly gentleman. Brer Rabbit hopped off toward the briar patch at 10 kilometers per hour, blah, 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 time. At noon, Brer Wolf began to chase him from the same starting point. If he caught Brer Rabbit at such and such a time, how fast did he run? All right, so what we've got is Brer Rabbit running to the briar patch and Brer Wolf chasing him from the same starting point and catching up. So what we have is another Lord of the Rings style problem because this is the distance of Brer Rabbit and this is the distance of Brer Wolf. All right, so that tells us the distances are equal, and so we can blow that out to rate of the rabbit times the time of the rabbit equals rate of the wolf times the time of the wolf. Now we can list and we can go back now and drag out those numbers. Like I said last time, I don't even try to make sense of that the first time around. I'm just trying to focus in on this. All right, Brer Rabbit hopped off toward the briar patch at 10 kilometers per hour. He did that at 10 a.m. Uh-oh. That's not a number of hours. That's a clock time. Remember that when we have clock times, we have to make a separate chart. And the chart looks like this. It's just a way to organize the information to make it easier for us to find out what's going on. This is the starting time. This is the ending time, and this will be the number of hours. All right? This is Brer Rabbit. This is Brer Wolf. Okay, I'm going to write what these letters stand for since this is our first time. This is the start time. This is the end time. And then we'll use that to calculate the number of hours. This is what we want up here, right? We don't want clock times in our variables. We only want the number of hours. Okay, so let's add that. Brer Rabbit started at 10 a.m. So rabbit, start time, 10, and I don't have room to write a.m., but I'll just write the a. At noon, Brer Wolf began the chase. Okay, so he started at noon. Okay, did you know that noon is 12 o'clock, but it's neither a.m. nor p.m.? And midnight is neither a.m. nor p.m. AM and p.m. refer to being after noon or before noon. So noon is not a.m. or p.m., it's just noon. Okay, 12 noon. Okay, if he caught Brer Rabbit at 2 p.m., okay, that means the race ended at 2 p.m. How fast did he run? All right, so how fast did the wolf run? This is the one we're going to be trying to figure out. We've got plenty of clock time here, though. We can figure out the hours and plug that in up here. If the rabbit started at 10 and ended at 2 p.m., that's 4 hours, right? He started at 10, so 11, 12, 1, 2. This guy started at noon. That's 12 o'clock, so he ran till 1, 2, only 2 hours, which makes sense because noon is 2 hours after 10, so we're cool with that. The time of the rabbit is 4 hours. The time of the wolf is 2 hours. The clock chart makes it a little trickier. John does not use a clock chart. I find it extremely helpful for helping us organize the data. Can you just calculate these hours in your head? Yeah, you can, but it's just one more thing and it's easy to make mistakes, and sometimes John's really tricky in the information he gives us. This was a pretty easy one. So I recommend that you master the art of the clock chart. All right, now we've got everything we're gonna get and we're ready to plug in. The rate of the rabbit is 10. The time of the rabbit is 4. The rate of the wolf, we don't know. The time of the wolf is 2. I like to put these in the same order as this. That makes it way easier to fill in. I don't even have to think about it. I just go right down the line. All right. 40 equals 2 times our W. I like my number before my letters. And all we have to do is divide by 2, and we get that the rate of the wolf equals 20. And now I'm just going to look back at the problem and find the units, because we should put a unit on that. And I don't think I did that in the last problem, did I? It's kph. Oh, that's because it was the distance, and we did write miles. The rate of the wolf is 20 kilometers per hour. That is 100% correct. Yay! So the wrinkle in this problem was the clock chart and organizing this information so that we can take clock times and convert them into hours. You know you need this when it gives you a clock time, like noon, 10 a.m., 2 p.m., instead of saying they ran for 3 hours, right? That's what we want, but John sometimes gives us this instead. Okay. That's all for type 1s. I hope they feel comfortable in your brain. I hope you feel like you're hanging out with an old friend. Now we're just going to do a quickie geometry touch-up. Is there even anything to do? I don't think there is. Oh, I know why. I know why. Let me just show you. John Okay, so we're talking about similar triangles. Similar triangles are triangles that have all the same angles but not the same sides. If we establish that two of the angles are the same, then we know that all three angles are the same, then we know that the angles are similar, then we know that the sides are proportional. And we can solve for missing sides by finding our anchor proportion and then setting it up, right? And that's the way I like you to do it. John does this scale factor thing, which I find annoying and unnecessarily cumbersome. Therefore, off with its head. What he's doing here is saying, oh, guess what, you guys? Instead of using that wacky scale factor thing, you can just use proportions. Well, that's what I've been asking you to do all along. So John's just introducing proportions that you already know. Don't worry about the scale factor. You're not missing anything but maybe a mild headache. And John is finally getting on the proportion train and doing it the fun way. Yay, that's all we have to do. Guess what? I don't even have to write on this piece of paper. I'll save it for next time. Goodbye.